now let's talk about multicollinearity and VIF and why it is important. VIF means variance inflation factor. So in today's video we will cover it. And VIF. Before I explain it, before I do the coding, you need to understand it and what does it mean and why it is important. So what is multicollinearity? It occurs when your independent variables are highly correlated with each other. And when it happens, the model gets confused and it gives credit to, it gets confused and it gives you values that are quite not stable. So how we need to fix it? And when it happens, it is a huge impact on the coefficients, especially when two independent variables are correlated. For this, to overcome this problem, we have variance inflation factor, which is a mathematical smoke detector to find and measure the redundant data accurately. Now to find the redundancy, we use the VIF decision scale. We use a standard scale to judge the health of our features, and if VIF is 1, it means that the situation is fine, it is perfect. If it is greater than 5, it is a warning zone, it is a moderate. But if it is greater than 10, then it's really danger. Okay, so you need to drop some of the features and you need to find where the problem is, and so you could adjust it. Now how VIF is calculated. Let's suppose you have features. Okay, let's suppose R&D is your feature and property is your dependent variable. Now to predict the dependency in each other, the VIF calculate use the independent variables and find the predicted score R square that we find, and for that we apply the VIF formula, which is 1 divided by 1 minus R square. We have a coding for that, which is quite easy. Now if you look at here, we have variable stat, admin, and marketing. These are your features, and R&D is also your feature. We don't have the dependent variable profit. So based on these features, we find the dependency which feature is strongly related to the other feature, and there we have the problem. So we need to drop the feature. We need to once you know that there is a problem, then fixing the problem is not that difficult. So for that we apply the formula 1 minus R square, and R square is your R square that we covered in the previous video quite in detail. So go back and watch those videos so you understand what's happening right here. Now the problem is with dummy variable is that if you forget to drop it, then the remaining states can perfectly predict the missing one and the resulting in a perfect R square, which is 1. And if you put in the VIF, which gives you infinity. So you need to take care of these things. Okay, now let's do the coding and understand how can you find it. Now from statsmodels dot stats outliers, let me just quickly type it. Here we have to import the variance inflation factor. Okay, now we need to calculate VIF and the training data only. So VIF requires a constant, just like stats model OLS did. So now let's just define a variable xtrain and let's call it VIF. Okay, now the next thing we need to do is we need to use the numpy and use append. Okay, here we define array and then np dot once. One thing you need to know that the state model doesn't have b naught, so for that we have to use the ones column. Okay, so here if you remember that our training data we have 41, it was its shape. Okay, there is also another method for it in case you just don't remember how many rows are were in your training data. You can also do that automatically. Okay, so now here all we have to do is that call the xtrain, and the next thing we need to do is we need to use access. One thing more is that we forget our bracket. Axis is 1. If you look here you can see that our xtrain shape is 40. Okay, now what we need to do is we need to calculate VIF for every single column. Okay, to do that we will find a range, a loop for I in range, and here the loop will go through xtrain. Okay, xtrain VIF. Okay, this is our new variable that we define. You shouldn't go through the xtrain, the old variable. Okay, you shouldn't go through that. And now here we need to add the shape 1. The next thing we need to do is don't forget your colon here. Okay, we need to define VIF, and this is our variance inflation factor. So variance inflation factor that we already import here, and here all we need to do is just call our xtrain. Okay, it will work on this xtrain, and it will loop through I. Okay, now all we need to do is just do the front, and all we need to do is just column. Okay, and xi. Okay, so here since we have represented our coefficient as b, I think, yeah, so bi, we will use b here, and VIF, and this is how our VIF value will be found. So I will add two decimals, and if you look here we add some extra bracket here. We need to fix it. One more important thing is that you have to add s here, then run it, and you will see the output here. So as I said that if the value of VIF is equal to 1, it is perfect, no correlation. If it is greater than 5, it means it is a warning, moderate correlation. And if it is greater than 10, it means that you are in a danger zone, the correlation is very high. Now we have to skip B naught. Okay, this is our intercept. It is not important, but the rest of the value you can see B1, B2, B3, B4, B5, and you can see that all the coefficients are fine. Okay, there is no big, all the values are below 5, so it's good, it's not bad.